The heat that powers the Yellowstone supervolcano and all those amazing geothermal features comes from an ancient anomaly in the Earth called a hotspot.
And this hotspot has never moved, but it used to be about 150 miles away in Idaho under a different park called Craters of the Moon, where it caused some powerful volcanic activity that may just erupt again sometime soon.
Let's unravel this geologic paradox today on 9 Worlds. The currently dormant volcano at Craters of the Moon National Monument is one of 4 in the state of Idaho. And despite what you read about impending doom at Yellowstone, read all about it, the volcano at Craters of the Moon is far more likely to erupt next, most likely sometime in the next 100 years.
But the story of this Idaho volcano actually begins with the hotspot that is currently under Yellowstone National Park. According to the mantle plume theory, hotspots like this result from uneven heating related to radioactive decay deep within the Earth. Material that is hotter than that surrounding it rises up through the cooler parts of the Earth's interior in a plume very much like the red wax inside a lava lamp.
And just like a lava lamp, the plumes you find in the hotspot produce successive batches of magma that can eventually reach the Earth's crust and burst forth as lava. But lava lamps don't actually produce magma.
No, but they're very cool.
Yes, true.
The hotspot currently under Yellowstone is stationary relative to the tectonic plates that make up the Earth's surface. But the North American plate has been moving southwest over the hotspot, making it appear as if the hotspot is moving in a northeasterly direction. As a result, the hotspot has left a trail of volcanic activity in its wake across the Snake River Plain in Idaho, a trail that gets older as you work your way back to the start of the path, which originated 17 million years ago at the McDermott volcanic system near the Nevada-Oregon border.
The older volcanic centers you find along this path are essentially ancient Yellowstones, and one stop along this path was Craters of the Moon.
Around 8 million years ago, the Yellowstone hotspot was beneath Craters of the Moon, causing the especially violent eruptions that you see with these kind of hotspots in the Earth. Now, as the magma formed within the Earth's mantle reaches the crust, it melts the surrounding rock that is rich in silica. This forms a magma that is thick and pasty called rhyolite. Gases in this magma cannot easily escape, so the eruptions from this kind of magma tend to be violent and devastating. When they happen, they can send hundreds of cubic miles of material into the atmosphere and eventually create large calderas once that magma chamber finally empties out.
The Yellowstone hotspot continued to produce these intense, violent eruptions along its path as it moved, eventually causing the massive caldera at Yellowstone.
But the hotspot also leaves behind something else in its wake. Eventually, those initial violent eruptions of rhyolitic magma are replaced by eruptions that are relatively gentle by comparison and composed mostly of basalt from the magma chamber that formed during the first stage of eruptions.
These are more like the eruptions that happen now, today, at Craters of the Moon.
Now, magma continues to rise and generate pressure in the chamber under the Earth, but now most of the silica is gone, so the magma is basaltic in nature. As pressure builds, this basaltic magma eventually finds fractures in the Earth's crust in areas where it's been pulled apart and faulted. These fissures create pathways for that magma to move towards the surface in basaltic lava flows that then cover the older rhyolitic magma, leaving behind dark black basalt features like those we see at Craters of the Moon. The 8 eruptions at Craters of the Moon during the past 15,000 years are probably in part the result of basin and range faulting. Recent eruptions have been occurring along fissures in the Great Rift that correspond to active faults in the Snake River Plain.
These are places where Earth's crust is being pulled apart and thinned due to plate tectonics. This allows more magma to be generated and more pathways for the magma to reach the surface.
The location of Craters of the Moon National Monument encompasses the Great Rift volcanic zone and contains an incredible concentration of volcanic landforms and structures along an area of more than 50 miles of fractures and eruptions, including 60 lava flows and 25 cones. This park has nearly every type of feature you'll find with basaltic volcanoes. And if you want to learn more, we have an entire video showing you those features and describing the eruptions that will likely happen here again very soon. Thanks for watching. We'd love to hear your questions and comments below, and we hope to see you again soon on the next adventure.